Okay, we will continue now the extravascular kinetic, and we will talk about lag time, and we will see if the time allows for other other subject other than the lag time. Okay, so according to whatever we just got and the or what we know from the residual method, we have this. Again, I will have it a little bit large paragraph, and we have CP versus time, and it was, if we are talking about similar graph, we have curve that will end with linear profile, okay, after the maximum. If we are doing linear regression of the terminal phase, we will have extrapolated line, okay, which is what we ever had before, and we will have the residual line, right? So this is our residual line, and this is extrapolated line. Okay, for when we are having both of the extrapolated line and the residual line the same point, which is, according to the equation that we have, it was the whole intercept. If we are talking about CB versus time on a similar graph, it will be A, which is KA over KA minus K multiplied to the fraction dose over VD, right? So again, if the absorption start at time equals 0, then I will have both of them, the intercept of both the terminal phase linear regression or the extrapolated line or the linear regression of the residual line. So the intercept of the linear regression of this and the intercept of the linear regression of this will have the same intercept. And again, this is what we already said in this part, if you remember, right? Whatever the drawing that we have, either it's len or log. 1 second. See, we have it in len and we have it here in log or a similar graph. All of them we will have the same, yes, the same intercept. Okay, what if, which is the y-axis, right? Intercept. What if the transport, the absorption didn't start at, okay, if we consider our profile like this, and the transport, the absorption didn't start at time equals 0, it started time more than 0, then this is no longer what? Y-axis intercept, right? This is no longer y-axis intercept. It's now called the intersection point between two lines, right? The one that is related to extrapolated, which is related to elimination, and the one that is related to absorption, right? If, again, we have the extrapolated line, if the absorption started time equals 0, as this, anyway, it won't work. So if the absorption start at time equals 0, so we don't have this, we don't have any delay in the absorption, then the y-axis will be the intercept that I have, and it will be the same for both of them, the residual line and the extrapolated line. But if the transport didn't start at time equal 0, and it took time for the absorption to start, which is time more than 0, it means that this point is no longer the y-axis intercept. It's still the constant that I know, but it's no longer the y-intercept, and now we don't call it a. I will just tell you in a minute why is this. Okay, then we will have an y-intercept that is related to absorption, which is this one. We will call it a. This is y-intercepts. Okay, and this is the first one, which is related to absorption, and another one that we call it B, that is related to elimination, right? So again, usually we will have them if we start the absorption at time equals 0. We will have the constant that we know as the intersection point, and it's the same as the y-axis. But if the absorption took longer time than usual and it didn't start at time equals 0, now we have this as the intersection point between the extrapolated line and the residual lines. Okay, this will be the constant that I already know. Then we will have different y-intercepts, one that is related to absorption and the other that is related to elimination. This happens when we have this, which we call it lag time, okay, or T naught, okay, which means that the drug didn't start the absorption directly, or the absorption didn't start of the drug directly, okay. This may happen for different reasons, either physiological factor such as motility or emptying of the gastric tract, or formulation related, which is we may have some issues in disintegration, dissolution, or even the release from the drug. Okay, so it's whatever the delay that we have prior the start of the absorption. Okay, again, the lag time is very different than the onset of action. If you remember, what is the onset of action? It's something related to some information that I know from the therapeutic range, right? So the onset of action is the time that the concentration of the drug equals or more the minimum effective concentration. This is the time prior the start of the absorption of the drug. So they are totally different as time. Now, how we will use the model that I know, the kinetic model that I know for extravascular to determine the parameters or concentration that I need. We have already, let's write it here, this equation, the equation that we have for extravascular, which is our constant, and then one that is related to absorption, elimination, and one related to absorption, two constant terms. If you remember, this was the time, whatever the time that I need to measure the concentration at, right? So if we start here and I need to make the concentration, to know the concentration here, I will just add the time since 0, okay? But if I will use the same equation that I know, but I have some initial time before the absorption, I need, if I have this time, right? I need to know the concentration at this time. I need to determine the right time in which I need to take this out of it, which is the lag time. So it will be T minus T naught, T minus T naught. So if the total time, I will add the numbers in another on another paper to make it easier to understand. Okay, as example. Okay, this if I want to use the constant that I know. Okay, if I have details about Ka, K, F, X, and Vd, and I know the lag time, total time, so I will be fine to use this equation model, but make sure that you remove the lag time out of it, of the total time. It's similar to the idea, or it's the same as, rather, I don't have this, I have this, I'm shifting the profile, so I take this out of it. Okay, so I'm doing some correction math-wise. Okay, if I don't have information about the intersection point, but I have some information from here, which is usually happening when you do the, as we said before, what? The linear regression. And let's say this is 1 and 1 minus C X plus, it will be different constant or different intercepts, right? We have different intercepts. This is the same as B, and this is the same as A. Okay, so those are my intercepts. So from the, if we have linear regression of the both lines, we can determine the intercepts. And now what I need to do, it's the other way to deal with it. It's, I will take the constant that is related to elimination and the constant that is related to absorption, and I use the total time. Okay, so this will be my total time since 0. Okay, and both for this. So I don't have information about this, but I have information about both of those, so I can use the intercept. Okay, which is, if you just go back in how this equation happened, we have this multiplied to this minus this multiplied to that. But it's the common factor between both of them. That's why we have it outside the parentheses, right? If the intercepts are different, then we will not have a common factor here, so we won't take it into consideration. Okay, just as numbers to make it easier for you to understand. We have, not sure what is the time now. Okay, so if we have this, and I'm telling you that this is equal to, let's say, 2 hours. Okay, and we have this. Okay, so we have this, we have here okay. If I told you that I need the concentration at, let's say, 12 hour, and I didn't determine if it started from the absorption, so at 12 hour I need the concentration. Okay, total time is 12 hours, and I want to use the first equation in which CB at certain time equals Ka minus K, which is my intersection point, right? According to this, I need to do what? Right? To correct for the time. So this will be equal to 12 minus 2. 12 minus 2. As I'm shifting to make this my whatever you know already, shifting and removing this out of the equation or out of the time. This is the first way to deal with it if you have information about the intersection point. Okay. And the other way that I have information about this and this, so CB at certain time, which is needed to be at 12 hours total, equals BE minus K time minus A minus KA with time. What is the time will be here? If the whole thing is 12 hours and I'm using this and that as intercepts, right? Then this time will be equal to total at 12 hours. This will be 10 and this will be 10. Okay, this is the difference, and I hope that hopefully this was easy to understand. The only thing that you either correct for the time in the first case, or either you take into consideration the whole time that you have. Okay, and this will be the end of our video, which is number 6.